Mark here, welcome back to Mk1 Mechanics. In this video we're going to clean up the CAD file and export it for prototyping. So I got a tip from Zach Lerner about something that I want to update right here in that corner in the CAD file. And what he said is to use a chamfer on the steel ring in that corner. So I'm going to update that real quick. I've deleted the fillet and going to redraw that with just a straight line and making sure those are still constrained along the horizontal and vertical constraints so that they're useful. It's at the angle 135, so it's like a 45-degree cut on the other side, and fixing the length of it will then fully constrain that steel ring. So what Zach said is this makes it easier to and cheaper to produce and fit the steel rings. Good machine shop will make that change for you anyways, but I would prefer to include that stuff in the file if possible. So taking a look at the final specs here, it's looking like 63 and 2/3 of a gram for the assembled Yoyo, using my estimate of 2.8 grams for the whole guts. So I've zoomed in here on the bearing post actually. So I want to take a look at a couple things. So this post is got a couple things going on. I've tried to get it to have a lot of thread engagement where the axle can screw into the post down along that line. So you can see there's about 3¼ millimeters currently, and I've set that as a reference constraint, so it'll update. It's not a driving constraint, so it won't fix it to that length, but it'll tell me how long it is. And I've also added a constraint to the distance between the post and the center line. So if you double that, that'll be the distance between the two posts. That 1 millimeter section is roughly how much of the post is actually interfacing with the bearing. If that is very long, then it becomes super difficult for the bearing to be installed or removed. If it's too short, however, then the bearing will always feel loose, and it won't help the two halves like stay concentric with each other. I'm just sliding constraints around and double checking everything in here. So I've also decided I'm going to adjust the gap down to 4.44 millimeters, just make it a little bit smaller. Hopefully it'll help it feel better on the throw and the bind. So I'm double checking the distance between those two parts using a reference constraint, so it's not over constrained. It's very thick there. The thickness of that section is kind of like determined by the shape of the cup. And then on these other sections, like going up the body, I aimed for like a minimum of 1.3 millimeters, which may be a little bit conservative for the 7075 alloy. And where the ring is fitting, it's a 1.2 instead. But that looks good. So what I'm going to do is select both of those parts, hit Control E and export as a DXF 2D. That'll bring up the export dialog. Hit OK. And it will create a DXF file. So I'm going to double click and open that. I have another piece of software called LibreCAD, which is pretty much only for viewing working with 2D CAD files. I just want to double check and make sure that the two parts are separate sections in the DXF, and I'm just looking at everything to make sure it all looks good with no discontinuities. And you can see that new chamfer on the inside of the steel ring, so that looks good. So that's ready. And the next step is to prepare notes for prototyping. So when you're preparing something for actual prototyping or production, it's a really good idea to write down all your notes in a text file, including all the specifications of the design and all of the other details that a machine shop is going to need to actually produce it. So this yo-yo is 44 millimeters wide, has a diameter of 53 millimeters. The body will be 7075 aluminum, and the rings will be stainless steel. The axle will be an M4 axle at 8 millimeters long. And it's not always clear just from looking at the 2D CAD file how long the axle is supposed to be, unless the center point is lined up correctly. So it's important to specify. For the finish, I want a 220 grit blast on the surface and anodized. We'll pick a color at some point, unless you want to order like raw prototypes. I'm not really interested in raw prototypes right now because it can be a bit harder to like test some parts of this yo-yo design, which is going to be good for finger spins hopefully, but not if it has a raw finish. Yeah, so I talked to my team, and one of them had an idea for a name, the Spyglass, which fits into the optical theme of some of our yo-yos, to go along with the diffraction in Umbra and so on. So I grabbed some telescope emojis from off screen, and there we go, Mk1 Spyglass. So for the color and quantity, I need eight of these for me and my team, so I can send one around to everybody. Some machine shops will only really make 5 for a prototype, which is fine. If I need to do that, that's okay. But I don't really need more than 8. Then I just end up with extra ones sitting on my shelf. So for the color, there's a couple options. I'm probably gonna go with the sort of like silver with rainbow torched ring. As I'm trying out a machine shop, and I want to see how they do with that look. So it'll be easy to tell how well anodized it is with that kind of color, because you can't hide anything with like a dark dye and so on. And I've got the specs that I've exported from FreeCAD there for my reference. I'm not going to send those to the machine shop because those numbers don't really mean anything to them. So the general process for prototyping is, once you have a design that you're happy with, and you kind of have like a concept for how you want to like produce and market it, you need to find a machine shop that can number one, do all the stuff that you want for the design in terms of like material and construction. And for me personally, I like to use machine shops that handle the anodizing themselves. Whether they outsource it or do it in-house doesn't matter much to me, as long as they're managing it. So I don't have the time or the expertise to figure out anodization really. It's really far out of my wheelhouse. So once you have a shop in mind, or multiple shops, you can get quotes from them. Most of them have pretty standard prototyping rates, which are expensive per yo-yo, but that's just how it is. It's time consuming and annoying for them to make very small runs. You should also ask at this point like what their availability is, like whether they have a lot of things that they need to do before they can produce your yo-yo, especially if you if like this is the only project you're working on, you might want to find a shop that can make prototypes more quickly so you can get them. If not, it's okay for you to wait, then it doesn't matter as much. So all of the notes from the list above is what I would send to the machine shop. And if you've picked a color, it's usually helpful to send a Pantone color swatch as well, so that they can compare colors more accurately. If you have any other questions from the machine shop, you should ask them ahead of time instead of after the fact, especially about things that you don't know a lot about, like, hey, like what different types of surface finish options you have, like raw, polished, bead blast, a matte blast, like what sorts of different amounts of blast that they may have. And then after you've got all that sorted out, you have your quote, it'll be time to arrange payment. It might be like 50 or 60% down, or all up front, depending on which shop it is. And don't use a wire transfer. Use PayPal goods and services if at all possible to do, for your own safety, even if it costs you more, because you will certainly regret it if you run into a situation where you wish you had paid with PayPal goods and services. So after that, it's time to be patient. If the machine shop is good at communicating, they'll send you details and photos along the way. It's always okay to ask for them, so that you can kind of see how the process is going on their end. They may have like, hey, here's the yo-yos that came off the lathe. Look how shiny they are. And then the second longer step of waiting for anodization, assembly, testing, and so on. And then they'll arrange for shipment, and eventually you'll get the yo-yos in the mail. So, and now the rest of the process has begun. So once you have the yo-yos, you might have some other people you want to send them to for testing. Get out a notebook and write down all your thoughts on it, and take careful note of all the details to the yo-yo, any sharp edges, any parts that don't feel comfortable, anything that feels weird about the throw or the bind, or how the string interacts with it. With the notes written down, you can consult those, and make a copy of your CAD file and your exported DXF, and file them away somewhere, because those two files are something that you actually produced. So you want to take note of that and have it ready to go. And then you can effect your changes on a new copy of the file, and hopefully things will go great from there. And when do you know if the yo-yo is ready for production? So if you have a big list of changes to make in the yo-yo, and you make the changes and you compare them side by side with the original version that you prototyped, if they're not too far off, and like you can like justify each of the changes as something small, then you may be able to get away with sending all those changes directly into production. If you have much bigger changes to make with the yo-yo, like diameter and width changes, or really big like weight distribution changes, it may make sense to order additional prototypes with those changes to see how they feel to you. And that's it. I am going to send this yo-yo off for prototyping, and hopefully we'll see how they turned out in a month, in a couple weeks. Who knows?